is my screen up there? Okay, great. So this is automating your Angular projects with schematics. And I wanted to give this talk because schematics are used somewhat in the Angular ecosystem, and I think they're very cool, and I think a lot of people would find value in those. So we're going to talk about how we can get some of that value. So first of all, I know everybody's really sleepy. You've been sitting through all the good talks all day, and this is the end of the day, last talk. So, but we'll get through it together, right? I was right there with you when I got here a couple of days ago. So, as we mentioned before, my name is Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts. I tweet out GIFs. I talk about sports, and I block people on Twitter sometimes because that's just what you have to do. Software engineer at Nrwl, which you heard about earlier when we gave our sponsor talk. So good thing there. Also a GDE, gotta list all these titles, right? And also a maintainer on the NgRx project. So I'll just plug that if you want to get involved there. You can always do that, or get involved with Nrwl or NX. You come see us there also. So the areas that I wanted to cover are, what are schematics? We'll give a formal definition and talk about the kind of key terms that you come across when you use schematics. Talk about why you want to use them, what are the use cases and examples, how do they work, the different pieces that you'll interact with, and different tips that I've come across while building schematics and just things that I've learned along the way. Because I want to make schematics not so scary, so we'll see how we get there. So what are schematics? Schematics are used for scaffolding. They are generators that perform operations on your file system. Like I said, a big usage of schematics is for scaffolding. When you set up a new project, or there are things that you consistently do over and over when you're working with your applications, you want to automate those things, and whether that be generating additional configuration or updating files or existing files, maybe you have processes within your organization, schematics help you along that path. Do those things not repetitively. You can automate those. So schematics are very popular, like I said, popular in the Angular community, but they are independent of the Angular framework itself. They're part of the Angular dev kit that provides low-level APIs that you can use. You want to write schematics that target your own needs. As I mentioned before, there are things that you may do in your own projects or at your job that you can take advantage of schematics for. They're also popular with many third-party libraries in the Angular ecosystem that use schematics that you just kind of use as part of your daily routine. So just to give an example of some of those, I mentioned the Angular framework uses schematics, like when you set up adding like PWA capabilities to your app. There's also CLI, of course, is probably the biggest consumer of schematics for all the generation and update commands. And of course, Angular Material has predefined schematics for like dashboards, navigation, and other layouts. And of course, if you've used NgRx before, we make heavy use of schematics to aid you in setup and development of features. And I talked about NX that uses schematics to generate components for Angular projects and even React projects. So as I mentioned before, it's not necessarily just Angular specific, but it's very flexible in things you can do. So I want to talk about the schematics in kind of two areas. There are schematics APIs in the two concepts, schematics APIs and then configuration. So as I mentioned, Angular Dev Kit is the namespace where all the schematics APIs are. So we'll go through some of the definitions of what these are and their common use cases, just so that when you attempt to do schematics yourself, you'll know the terminology and it'll seem more familiar. So the first one is a rule. I'll just go through the terms here. There's a rule, there's a source, a tree, engine, and I'll, like I said, explain these a little further in detail. And then there are also utilities that they offer to build schematics. So then in your configuration, there is a schema that you define for your schematic, and then the collection that defines the number of schematics that you offer or the number of ones that you've written that you can execute on a project. So as I mentioned before, the first one is a tree. And a tree contains your original file system. It's more like a staging area for changes. It kind of works somewhat similar to like Git. You make some changes, you stage those, but it doesn't commit those changes yet. It's just a staging area. It uses a virtual file system where, like I said, it can perform changes against the staging area without actually impacting your file system yet. It's built on top of Node APIs so that you can ensure that there's cross-platform compatibility. The next one is a rule. So the bulk of what you'll do with schematics are rules. And a rule is a function that applies to a tree. Most of the time you write functions that return a rule, and that will get applied to the files that are in your tree, some files you want to operate on. And they are immutable. So rules don't modify the existing tree. They return a new tree whenever they perform an operation in that staging area on it. So it will contain all those transformations that are to be applied when you're writing a rule to apply against a schematic. Next is a source. So a source is a function that creates an entirely new tree. This could be from an empty file system. You could read in existing files that are bundled in your schematic. These are considered sources. So a URL is one of these sources, and it just reads in files that are loaded in from a given file or given URL and returns a tree with those files. So let's take a look at a schematic in its simplest form here. And that's something I want to emphasize is that schematics add value that's worth the investment, right? So writing simple schematics is pretty straightforward, and they can help you, help others. You know, you invest in these schematics and people take advantage of them. So this schematic is pretty simple. It just has it's just a function. It takes in options. And this rule creates a file, just a markdown file, just for example, and writes those contents to that file. So to define, for a schematic, each schematic has a defined schema. And the schema helps you define properties and options for the schematic that are available to the user. So it's also used to validate input for the schematic itself. So the schema is defined in a couple of ways. It's defined in JSON and in TypeScript. And the JSON is used to declare the validation for the available options. It supports many data types. So if you looked at schematics before, you use NgGenerate. It can be you provide things that you request a string, or if you pass the routing flag, it could be a Boolean, or even lists or prompts are enabled in the most recent version of the Angular CLI. So here's just an example of the JSON schema that you would define for a schematic. The couple of properties here that exist are name and service options. The name has a description and a type, which is just a string here. The spec here has a description, a type, and a default. So it gives you flexibility. If you want more custom options, you can provide those, such as prompts to receive user input, if you want to provide a custom list or other information. But this is just declaring what the schematic properties are in the JSON. The TypeScript file is used to define an interface that you adhere to when you're creating rules. So when your schematic runs, it parses those options that you provide, and this gives you a type-safe way to consume those options in your defined rules. So when I defined the schematic before, I just had any as my options, but I can import that schema and have typed options of what's available for my rule that I write for a schematic. As I mentioned before, collections are defined in a JSON file, and this is just the path to the collection is defined in your package JSON file. So in your collection, it's just going to list all the schematics that you offer, whether they be ones that modify files or generate files. They all have the same structure here. They have a description of it gives you help options for that schematic, the factory function that I've talked about that returns a rule, and the schema that provides the validation for that. Also talked about the virtual file system. I said it uses Node underneath to create like a host system so that it's not applying changes directly to your system as it's running. And also represents your file system, like I said, virtually that you can operate on. And has those stage operations that you can chain together to perform multiple things. So if you look at another simple example of a schematic, you can create files, you can read files in, read files, modify them, and all these things aren't, like I said, they aren't applied instantly. So you can do multiple things at once and change them together. So the schematic engine is something that you don't normally interact with directly. The Angular CLI uses it internally to control the creation of a collection and execution of the schematics. It does things underneath like create workflows and schedule tasks, such as package installation using the package manager of that it detects from your system. It also brings together the virtual file system as a host, reads the metadata from the collection and the changes to apply. And then once everything is the verification checks pass, it commits those changes to your file system successfully, and then that's the end of that particular workflow. So what can I use, or what can you use schematics for? As I mentioned, the big thing is automation of common tasks, things you do repetitively. Standardization. If you know your company creates your features in a certain way, you can standardize that with schematics. You can use this in large and small environments that you'll get enough impact either way. Structure and process. The way you do things in an organization, you want to keep those, like I said, a certain way. So file generation, you can also use them for file generation using standard and dynamic templates. So these templates, if you just want to generate files that don't require any changes from the user, you can just use those to generate them, or you can customize them and make them more dynamic. You can use these for install tasks. Things such as adding prettier or jest or your own custom setup to your projects. You can use schematics to automate these things and update tasks such as updating files within your code base. So as I mentioned, file generation. You're most familiar with the Angular CLI NgGenerate command for generating components, services, and other items. And these are using defined templates that can be static or ones that are not based on user input, and dynamic templates that generate different output based on the user options. So they're extremely customizable. Because, I mean, at the end of the day, we're like making copies of files for distribution and trying to make things easier. So there are a few template utilities that you come across when you're writing schematics. So I'll just list a few of those. The apply function, as I mentioned before, helps you apply rules to a source of data. I showed before you can read files in from a URL and apply rules to that source. Apply templates is when you're dealing with dynamic data that you want to apply to a specific schematic template. Use URL for loading in files to move those from a staging area to their permanent location, because you can have schematics that are bundled with their, or files that are bundled with their schematics to use those. So as you mentioned, move, and then there are string utilities to manipulate strings into many different cases, whether it be Pascal case or camel case or in their title case, many of the different ones. So these come from two main areas, the Angular Dev Kit schematics and the Angular Dev Kit core. So just a few imports that you use when you want to build these schematics. And what you import these, so let's say I want to generate a service. I want to generate some files from that I have stored in my schematic. Well, once again, you define a function that returns a rule. The files directory here reads those files from that schematic, and this is where, like I said, your templates reside. The apply templates lets you set properties and methods that are available to the template. So here you see that I have the classify and like dasherize methods that I can use to make those available to the template to make them more dynamic in case I'm passing in data to that template. I can also provide you can also provide your own properties to the template. Here I'm just providing an additional name and API endpoint for the template schematic, or for the schematic template, excuse me. So the template itself is just, in most cases, just looks like TypeScript. I've added a .template extension here just to makes it easier to parse, because it won't be compiled as part of the rest of your schematic code. So that's one thing to note, just to denote them that way with a template extension. So here I'm using the classify function. I'm taking in the name. I'm just using, I have a schematic template here for creating a service with a custom with HTTP client installed, already injected. So you can think of this as something you do quite commonly, so a schematic fits well here. So when that schematic is run and that service is generated, it will replace those items in the template with the options provided from the user called with those functions. And then you can, of course, move on and do things with the service as opposed to having to generate the service, import HTTP client, and do all those things that you would normally have to do. As I mentioned before, common tasks including register with Ng modules. These are things that are done with schematics, generating components, other items that are generated as part of your development process. You can think of other things like updating your constructors for a file that's already generated, modifying configuration, and generating organization-specific files. So for automation, there are a couple of ways that you can leverage schematics to update files. The first one being just a find and replace. You can read in the contents of a schematic, find and replace, and the second part is ASTs. So in general, find and replace is easier to implement. You're just reading and overriding the contents of a file. And of course, you can use regex, or if you want to get fancy or anything like that, but I think we know what happens when you try to write regex. So there's a more consistent way, of course, to manage these file changes, and that's with an AST. So what is an AST, and what value does that provide? AST is an abstract syntax tree. And what that is a structured representation of your code. It gives you a way to process that each line in your code represents a token or something that you can iterate over. It's represented as a tree of nodes. So TypeScript gives you the ability to generate an AST pretty easily from your code, from your TypeScript code, so that you can look at it and see the nodes. There's a wonderful tool called or a site called astexplorer.net, and you can actually paste your TypeScript code here and tell it what kind of language you're looking at, and it will give you an AST of that structure. So you can see all the different nodes, what the whole string, and you can look at different languages and see how you can parse that code. So as I mentioned, TypeScript has methods to let you create an AST, and as I mentioned, ASTs are pretty complex in nature, so you could give a whole talk on ASTs themselves. But as I was just showing here, you can create an AST for a given file path and its contents, and it'll give you get a hold of that AST for the code so that you can traverse over its nodes and replace them as needed, as opposed to doing a file replacement or regex or something like that. As I mentioned, it's more complex, but it also provides you more flexibility as you can target specific nodes, and it's just more targeted in nature. So install tasks. The most common one being ng-add, installing additional dependencies, and setup and initial setup of files. So if your library or using a schematic, it's pretty straightforward if you don't need to initiate any additional file changes. You create a rule, your rule receives the tree, and uses the schematics context to add a task to update your dependencies. And then you lastly return the tree. So just even basic support for ng-add for your library is pretty straightforward. There's also update tasks. These are just similar to ng-update. When you run ng-update using the Angular CLI, behind the scenes, it runs migrations that are defined in your library. So migrations are run between matched versions. They handle subtle modifications and updates to your library that may not be breaking changes, but they also help you transition your code base from one major version to the next. And that may include breaking changes. So migrations can give you a way to migrate those changes, like I said, whether it be file updates or transforming files through AST changes. So the same pattern here, you have ng-update, and it points to a migrations file in your package.json. And if we look at the schema for a migration, it looks pretty similar to a schematic. You give the schematic a name, a description, the factory function, the factory function that it references, but it also has a version number, so that in the future you're going to accumulate these migrations over time, but they're only going to be applied to that version that it matches and forward, because it's using semantic versioning under the hood to check those versions to see which migrations it should apply. Also, if you're providing a set of writing schematics or providing a set of them for developers, it's just a few tips. Extending the Angular Schematics collection is a way which you can extend multiple collections that give you a standard set that you can fall back to when if you want to set your schematics as a default and then have those be the fallback. Use sensible defaults. You want your schematics to be customizable, but you don't want to overload your users with too many prompts or options out of the box. You want to give your preferred method or preferred output by default, and then give them the ability to customize those. Use utility libraries or sites, as I mentioned before. astexplorer.net lets you look at the AST just online by pasting the code in. There's also tsquery, which is great for working with ASTs. It has a syntax similar to CSS selectors, that you can use. And even the Nrwl workspace schematics, or Nrwl workspace library has a lot of utility functions because we've written a lot of schematics before, and common functions that you can use to modify your package JSON files to just make those easier to work with. Also, I would tell you to compose your schematics. In most cases, you can lean on the existing schematics that are out there. If you write a rule, write a factory that returns a rule, you can use external schematics that aren't built into your library, such as the same ones Angular CLI uses, which is in an example here using schematics/Angular. So you can generate a component and a module and chain those operations together without having to recreate those component or module schematics in your code base. So to recap, schematics are generators that perform operations on your file system. There's a lot of value in automation of these tasks that you can invest in that will help your team be more productive because they're not having to use that time to do those things manually. It helps you standardize their development. I showed you examples of how to use ng-add or use ng-add functionality or ng-update functionality in your library, and using utilities to build schematics. So if you haven't seen Brian Love and Kevin Schuhart's talk on schematics before, I talked to them before, and they gave me some good insight about just the tools in general. And the thing that stuck out to me was, he said, don't write too much code just to write a little bit of code. So schematics are powerful. They can do a lot of things. They're very flexible. But you don't need to take a hammer to every single thing that you want to use them on. So if you want a GitHub repo of the schematics that I've mentioned through this talk, you can visit the URL here. And this has, like I said, has an example of using a schematic in an Angular project that you created with your library. And I hope you found this talk informative. I hope you go out and try to create some schematics yourself. And of course, you can reach out to me on Twitter if you have any questions, and I'll do my best to answer them. Thank you.